All right, welcome Algebra 1 students to another video. Today we are going to be covering lesson 3.4 and we're going to learn how to graph linear equations. Back in lesson 3.2, we did cover one way to write a linear equation, which we remember was y is equal to mx plus b. And we're actually going to save this form of linear equations for a future lesson. Today, instead, we're going to be focusing on a linear equation that's in standard form. So on the next slide, I'm going to show you what that looks like, what each of those letters mean in standard form, and then once we go through those, we'll go over how we could graph linear equations in standard form. So with that said, let's move on to the next slide. So linear equations can also be written in standard form. And if you're wondering what standard form is, it's this equation right here. We have ax, I think I have a laser pointer here. Yeah. ax plus by is equal to c. Now this equation might look a little confusing at first because you see there's a lot of variables, right? You're like, oh my gosh, what is a, what is b, what is c? We've seen x and y before, right? So we're going to cover what each of those things are. The a, b, and c, those are all going to be numbers in this standard form equation. So just think of any random number, right? And you're just going to pretend that a, b, and c in those places are these random numbers. So for example, if I gave you an equation like 3x plus 5y is equal to 15, right? We notice that here our a is going to be the 3, our b is going to be the 15, and our b is going to be the 5, and the c is going to be the 15, right? So that's what I mean by like a, b, and c could be any number you want it to be. And in this lesson, like they're always going to be changing, right? I'm not always going to give you the same equation all the time. So that's what a, b, and c represent, just any kind of number within this linear equation in standard form. Now, x and y are the usual. They're just going to be your variables. And we know that the x and the y values on a coordinate plane, we should know how to graph that as well. But we'll do a quick review on how we would do that. But before we get into that, I just kind of want to tease your minds a bit here. Let me see if I could do this. And then I do a blank screen. Blank screen. Nope. White screen. Yes. Okay. If I asked you, what is the least amount of points you need to graph a line, right? Some of you might be thinking, oh, we might just need only 1 point, right? So if I just had 1 point like this, and I asked you to draw a line, yeah, you can graph a line through 1 point, just like that. But if I wanted you to graph a specific line, notice that 1 point doesn't work because I could draw a line like this, a line like that, a line like that. There's like an infinite amount of lines you could draw through 1 point. So we don't necessarily need 1 point to graph a specific line. We need more. Let's try 2 points and see how that looks like. Let's say I had this point here. Let's add another point like right here. And let's try to draw a line that goes through these 2 points. And if we do that, notice that this line right here is one line that could go through those 2 points. But if I try to draw another line that goes through those 2 points, I can't really draw anything else, right? This is the only line that can go through these 2 points. So what I need you to understand is that if you want to draw a line or a linear equation, all we need is 2 points. I know in our quiz back in the day, we had 5 points, right? And that's kind of too much. It's a lot of work to show. So now we're only going to need 2 simple points to graph a line. And there are specific types of points I want you to graph. These are like the easy points to graph. That will help us create this graph for a linear equation. And this is where standard form comes in handy. So going back to our slides. That is not what I wanted to do. Let's see if I could figure out how to go back. How do I go back? Unwhite screen. There we go. Okay. So now that we know we need 2 points to create a line, here's a graph. And I'm going to show you the 2 points we need to graph a line or a linear equation that's in standard form. And the 2 points we need are going to be your x-intercept and your y-intercept. Now, what are your x and y-intercepts? Well, I'm just going to draw a random line, okay? Let's say I drew a line that kind of goes like this. I'm going to try my best. Hopefully it works. Like that. And then what I want you to notice is this line is crossing the x and the y axis. And wherever the line crosses those axes, that's going to give you your intercepts. So for example, in red, notice that my graph is going to be touching the x-axis right here at this point, right? We know that this point right here is going to be called your x-intercept because the graph is touching the x-axis, right? So I'm going to draw a little point there in red. This point right here, that is going to be called your x-intercept, okay? And then similarly, when your graph touches the y-axis, so for example, I'm going right here. When the graph touches the y-axis, that's going to give you your y-intercept, okay? So I'm going to do this in a different color. Let's do blue. This point right here, that is going to be called your y-intercept. So when the graph touches your x-axis, that's your x-intercept. When your graph touches the y-axis, that's your y-intercept. And the second thing I want you to notice is that for all x-intercepts and for all y-intercepts, this is always going to happen. Notice where the x-intercept, if I were to label that coordinate right here, this coordinate would be -1, 0, right? And I want you to notice that our y value there, or this coordinate, right, this y value is 0. And that's going to hold true for all x-intercepts. Your x-intercept's y value will always be 0. And I need you to understand that before we move on to those examples, okay? The x-intercept, the y value for your x-intercept will always be 0. And similarly, if we look at the y-intercept instead of the x-intercept, if I were to label this point here, we would call that 0, 2. And then again, I want you to notice, excuse me, that for the y-intercept, your x values will always be 0, okay? And again, I need you to make sure you understand that, because if we don't know that, then we can't really do the problems we're going to do on the next line. So first of all, x-intercepts, your y value for your x-intercepts will always be 0. And then secondly, the x value of your y-intercepts will always be 0, okay? So just keep that in mind. I do have in words here. So here's the x-intercept and y-intercept definition. So if you want to write that down in your notes, it's basically what I just covered, but in word form. So feel free to write this down, and feel free to pause the video if you need more time to write these vocab words in your notes. But with that said, we're going to go ahead and move on to the next line and start practicing how we could graph these linear equations in standard form. And again, before I move on, right, just to show you, right, I'm going to go ahead and read this for us. The x-intercept is the point on the line that crosses the x-axis, right? That's what I said. When the line touches the x-axis right here, right, that point is called your x-intercept. And again, note that the y value for that x-intercept is 0. Similarly, your y-intercept is the point on the line that crosses the y-axis. So again, here's my line. It crosses the y-axis right here at this blue point. And again, notice that the x value for that is 0, right? We found out that the x value will always be 0 for all y-intercepts. So with that said, let's go to an example. We're going to use the intercepts to graph the following equation. So here's our first example. We have 3x plus 4y is equal to 12. Now, how would I graph this equation, right? It's kind of, if this is your first time doing it, right, it's probably like, oh, I don't know what to do. But do you remember on the last slide, I told you that if I want to graph a specific line, I just need 2 points, right? And those 2 points are those vocab words we just covered, your x-intercept and your y-intercept. As long as we find those 2 intercepts, that's 2 points, we could graph our line for this equation. So the question is, how do we find those intercepts for this linear equation in standard form? Well, let's start with the x-intercept. And I used red for that one, so I'm going to use red again. If you have multiple colors, feel free to use multiple colors. But I'm going to write here x-intercept. Now, how do I find the x-intercept? Remember that key thing I told you, like the only thing I want you to get from this lesson, if you could only take away one thing, was that specific value. For x-intercepts, your y value is always 0. So watch. I'm going to rewrite the equation one more time. We have 3x plus 4y is equal to 12. But what did I just say? For your x-intercept, your y value must be 0. So do we see this y right here? We're going to replace that with a 0. And that's going to help us find out what the x value would be for that x-intercept. So watch. I'm going to replace that y with a 0 just like this. And now this is like a very easy equation to solve, right? I could just solve for x here. I know that 4 times 0 is just 0. So this would give me 3x plus 0. You don't even need to write the plus 0, right? If you already know that. We just know that 4 times 0 is 0. So now we just have 3x on the left side, and that's equal to 12. And if I want to solve this for x, all I would do is just divide 3 on both sides, which gives me x is equal to 4. Cool. So I just found my x-intercept. Remember, we want to write this as a coordinate, right? So if I have my coordinate, remember the first number is your x value. The second number is your y value. We just found out your x value is 4, right? That was this part right here. I know we have 4. And again, our y value we said in the beginning, for all x-intercepts, your y value is 0. So that would give us 4, 0. That looks very ugly. Let me rewrite that. There we go. 4, 0. So now if I plot that on my graph, 1, 2, 3, 4, 0, here is my x-intercept. Sweet, I got 1 point, just need 1 more, and I could create that line. And that second point we're going to use is the y-intercept. So remember we said for the y-intercept, in our definition, we said the y-intercept is when the graph touches the y-axis. And remember, your x values are 0 this time for your y-intercept. So again, I'm going to show the first part. You don't have to write the equation like I am. I just want to do this just in case there's those of you that are having trouble following along, right? But here's my equation one more time in standard form. Y-intercept is when your x value is 0. So I'm going to replace that x now with a 0. So it will look like this. 3 times 0 plus 4y is equal to 12. And then we're going to solve this for y, and that will give us our y-intercept. 3 times 0 is 0, so that just goes away. We just have 4y left now is equal to 12. We're going to divide both sides by 4 to get y by itself, and that's going to give us y is equal to 3. Sweet. So our intercept for the y-intercept, remember, it's going to be a coordinate. The first number is your x value. For y-intercepts, that means x is 0, right? So we have a 0 here. And then your y value we found out was 3. So then our y-intercept would be 0, 3. So here's 0, 1, 2, 3. Here's my y-intercept. And boom, we could graph our line. So again, I'm going to try my best here. I don't think I could really use a ruler on this thing. Actually, I probably can't. Let me see if I could do this. Oh, yeah, look at that. All right, cool. So here's my line that's crossing through those 2 points. And again, that's all the points we need to graph a specific line, right? I just said we need 2 points, and those are going to be your x and your y intercepts, okay? So that was our first example. I'm going to have one more example here for us to do before we do 2 u-tries, just so we could get some practice in and make sure we understand it. So here's our next example, 2x minus y is equal to 4. Again, I'm going to repeat this one more time. To graph this linear equation in standard form, we need 2 points, your x-intercept and your y-intercept, okay? So I'm going to write those down. We need to find our x-intercept, and we need to find our y-intercept. And remember, for x-intercepts, that is when our y value is 0, right? So here's 2x minus y is equal to 4. But if my y value is 0, it's now going to become 2x minus 0 is equal to 4. And then from there, if y is 0, right, we really don't need to write it. So I'm going to just write it like this. 2x is equal to 4, right? Actually, let me show that step. I think I need to show that. It's like this. But 0 is just 0, so we're just going to have 2x is equal to 4. And then when we solve for x by dividing 2 to both sides, we get x is equal to 2. Cool. From here, we can write our x-intercept, which is 2, 0. And when we graph it, that will give us this point right here. And then we'll do the same thing with the y-intercept. Your y-intercept is when your x value is 0 this time. So here's my original equation. We're going to make sure our x value is 0. 2 times 0 is just 0, so we're going to end up with negative y. Don't forget that negative. I know a lot of you forget those negatives. You got to carry that sign with you, okay? Negative y is equal to 4, and then to get that y by itself, there is a number in front of that y. It's that invisible 1. Technically, negative 1, because you have that negative in front. So we got to divide this by negative 1, so that those negatives can cancel out. So that would give me my y by itself, which is negative 4. So then my y-intercept, remember for y-intercept, your x value is 0. So I'll have 0, negative 4. And when we graph that, 1, 2, 3, 4, that gives us this point here. And then what we could do is grab our ruler or straight edge and connect these two dots together. That is not even close. Guess this tablet's kind of wonky. Yeah, that looks better. Okay. So that will give us this line right here. And that's literally all there is to it. You just find your x and y intercept, plot those points, graph them, connect the line that goes through those 2 points, and you just graph your linear equation in standard form. So it's really not too bad. So on the next slide, I'm going to give you 2 U-try problems. I want you to try it out on your own. So just pause the video as you're working on it. And then when you finish both of those U-tries, resume the video, and then you could check your answer with me. Okay. So here are the next 2 U-try problems. Go ahead and try it out, and then we'll check our answers together. All right, so when you're resuming the video, I'm going to go through these more quickly now because these are U-tries. So the first one, when we're finding the x-intercept, remember that's when our y values are 0. So I'm going to skip that first step where I kind of rewrote the equation. I'm just going to go right into it. So we have 5x minus 3 times 0 is equal to 15. This will give me 5x is equal to 15. Divide both sides by 5. We get x is equal to 3. So our coordinate is going to be 3, 0, which would be this point. Our y-intercept is when our x value is 0. So now that's going to be 5 times 0 minus 3y is equal to 15. The 0 times 5 is just 0, so we're just going to end up with negative 3y is equal to 15. Divide both sides by negative 3, and we're going to end up with y is equal to negative 5. So that means my y-intercept is going to be 0, negative 5, which would be 1, 2, 3, 4, 5. This point all the way down here. And then we're just going to grab our ruler and connect those together, which would give me this line right here. So that's how your graph should look like for the first one. For the second one, x-intercept, again, that's when your y value is 0. So we're going to have 2x plus 5 times 0 is equal to 10. This is going to give me 2x is equal to 10. Divide both sides by 2. We're going to get x is equal to 5, which means our coordinate is going to be 5, 0. Similarly, with our y-intercept, this is when your x value is 0. Ooh, kind of running out of space here. Let's see if I can fit 2 times 0 plus 5y is equal to 10. 2 times 0 is 0, so I'm just left with 5y is equal to 10. Divide both sides by 5. We're going to get y is equal to 2. So then my coordinate would be 0, 2, which would be, oh, I forgot to graph the first point. So here's 0, 2, and here is 5, 0. Once we have those 2 points, let's grab our ruler and connect those together. And it'll give me that point right there. Sorry, that line right there. And that's it. So hopefully you guys got the same answers during the U-tries. Again, a little recap. All you're going to do is you're just going to graph the x and y intercepts because we need 2 points to graph the line. Your x-intercept is when your y value is 0. Your y-intercept is when your x value is 0. Solve for them. You're going to get your 2 points, graph them, and then connect them together with a single line. And that's it. Before we wrap up the video, there are some special cases we want to go over. And these might look a little funky, and they might be a little confusing at first, but once you understand the idea, you should be able to go through these graphs pretty quickly. So for example, we're again just going to graph the equation, but how about if I gave you something like this time? It's just y is equal to 4. This might be a little confusing, like I don't know how I would graph that, but it's actually pretty straightforward. What this means is it's saying that your y value will always be equal to 4, no matter what. So what I mean by that is if we graph a table, or sorry, not graph a table, if we make a table, right, like an XY table, and what this equation is saying is no matter what, your y value will always be equal to 4 every single time, right? So what that means is in your y column for your table, it's just going to be 4 no matter what. It doesn't matter what your x value is. It will always be 4 for your y value. So just think of some random x values. Let's say I did like -2, 0, and 1, right? No matter what your x value is, your y value will always be 4, right? And if I have a table like this and I asked you to graph these values for this table, notice what's going to happen. If I do -2, 4, just to do a quick recap, right? This means that your coordinate is -2, 4. This is going to be your coordinate 0, 4, and this one's going to be 1, 4, right? So what you're going to do is you're just going to plot each of those coordinates. So -2, 4 is here, 0, 4 is over here, and 1, 4 is here. And notice what happens. If I connect those dots together, it's going to give me a nice horizontal line. And this is going to happen every single time for any equation that says y is equal to something. If you ever see y is equal to something, you should know immediately it's going to be a horizontal line that crosses through that value. Okay, so I want you to write this note down. Okay, so if you have an equation I'm going to write y is equal to b, where b is a number, right? It's kind of like do you guys remember the ax plus by is equal to c for the standard form? Those a, b, and c could be any number we want it to be. Same thing here, right? The b in this one's going to be any number we want it to be. So if you have an equation y is equal to b, where b is a number, then you have, or let's say you will have a horizontal line at that y value. So that's how you know how to graph these y is equal to equations, right? Right when you see y is equal to something, you're just going to have a horizontal line at that y value. So for example, looking at this again, we had y is equal to 4. Well, where is 4 on the y-axis? That's right here. So you're just going to have a horizontal line that just goes through that value. It's literally that simple, okay? So I'll show you in the you try it in just a bit how you could try it out on your own. You don't need to make all this table, right? This table is just to give you an idea of how it works. But once you understand this note here, you don't even need to show me that table, right? When you see y is equal to 4, just be like, oh, that's a horizontal line at your y value of 4. Here's my y value of 4. Boom, that's my horizontal line, okay? Now, let's try it one more time. But now, if I gave you something like this, where it says x is equal to -2. And again, I want you to think about that by creating a table again and see how that would look like. Let's say I created an x and y table for this. What does this equation mean? X is equal to -2. That means no matter what, your x values will always be -2 every single time. It does not matter what the other things say. It's just no matter what, your x values will be -2. So on your table, that means our left column for the x, every single time, will just be -2, right? It doesn't matter what the y values are. Your x values will always be -2. So just give me some random y values. Oh, -5, 1, 3. Sure, let's use those. Here's -5, here's 1, here's 3. Let's see how that's going to look like when we graph it. I'm going to use the same graph right here. Remember these coordinates. So this is going to be -2, 5. This is going to be -2, 1. And this is going to be -2, 3. Excuse me. So if I graph those coordinates, here's -2, 5 up here. Here's -2, 1, which is right here. Oh, sorry, -2, -5. Let me fix that. -5. So that means actually -2, -5 would be all the way down here. So there's -2, -5. Here's -2, 1, and then -2, 3, which is here. And notice that with these three coordinates, 1, 2, 3, if I draw a line that goes through those 3 points, notice that it's now going to be a vertical line. Just like that. That goes through all of those points. So that's what's going to happen with x is equal to something. You're going to have a vertical line that goes through that x value that you see. Okay, so we're going to write a note again one more time. So I'm going to erase this one up here. So if you need this, just rewind the video. But I'm going to write the exact same thing, but now we're going to do it for our x scenario. So if we have an equation, x is equal to, let's call it a different letter now. Let's call it a. I want you to understand, remember that these are just numbers, right? So let's write where a is a number. Then what kind of graph are we going to get? We're going to get a vertical line at that x value. That's what's going to happen when we have x is equal to something. So then you will have a vertical line at that x value. So let me show you how that works, right? So here's my laser pointer, right? We found out x is equal to -2. Okay, cool. That means from this note right away, you should know there is a vertical line that goes through our x value of -2. Where's x value of -2? Here's my x-axis. The -2 value is right here for my x-axis. A vertical line up and down is going to go through that value, which is how we got this graph right here, right? That's like the shortcut method. Do you have to show this table like I did? No, it was just to get that idea in your head, right? So now we should know if we see y is equal to, that's a horizontal line, left and right, that goes through that value. If we see an x is equal to, that's going to be a vertical line that goes through that x value. Okay, so with that said, here are some u-try problems. You don't need to graph a table or make a table or anything. You could just graph it right away. So this should take you literally like 30 seconds. Okay, so go ahead and try it out on your own. Pause the video, and then when you're ready, resume the video, and I'll show you what we should get. All right, so if you did this correctly, I'm not going to show the table because now we should know what's happening. If you see that x is equal to 5, then you know there's a vertical line crossing your x value of 5. Where's your x value of 5? That's right here. Right here's my x-axis. 1, 2, 3, 4, 5. Here's my x value. That means a vertical line is going through there. So you have a line like this that's going through that x value. Okay, so your graph should be, here's my ruler. Let's see if this works. Get a line just like that. That's going through your x value of 5, right? That's how we do the first one. Second one, same thing. If you have y is equal to -3, that means you will have a horizontal line going through that y value. So here's my y-axis, right? Where's your y value of -3 on this y-axis? Well, that's going to be 1, 2, 3. You're at this value right here. You have a horizontal line that's left and right that's going to go through that value, which is going to be like this, right? So you should have a graph that looks like that. So I'm going to grab my ruler, -3 is down here. And then once I graph that, you get a line just like this. Hopefully that's easy to see on the, I think that's good enough to see. Yeah. But yeah, these are the special cases, right? So every time you see x is equal to or y is equal to, you could literally just graph a horizontal or vertical line depending on what that variable is. It's as easy as that. Alrighty guys, that's basically the video. Remember, this was us learning how to graph linear equations in standard form. In the next lesson, we're going to learn how to graph linear equations in slope-intercept form, and I'll show you what that is in the next video. But before you guys head out, just write down the homework very quickly. So here's the section 3.4, page 133, and the following problems are your homework. All right, so go ahead and try that out to get that practice in so you know how to graph these linear equations. But with that said, thank you again, everyone, so much for watching the video. Hope you all enjoy the rest of your day, and I'll see you next time.